Suppose if you have any query, if you have any equation, or if you have any process, some processes will become automatically true, and some processes, even you expect true from that particular process, but it will give you no. Okay. So we need to identify which particular formula can hold a value of 1 that is equal to true. So that is the model. So anything has to be prepared in that model so that we must get 1. In case if anything we are getting 0, then it is indicated there is nothing working. Suppose if robo is getting the input of 0 for everything, any machine is giving an output of 0 for everything, then that means what, the machine is not at all working. We must say that the machine should take a signal something, and you must get 1 which indicates that you are in process, you're working, because in binary 1 is true and 0 is false. So we are having some assignments for any artificial intelligence system, and that assignment is having some formula, some process. If the process is holding a 1, that means it is the model, it is the correct model, the formula is correct. Okay. So in case if the formula X is yielding true for any assignment, then we can model it. It is the original model. If it is giving 0 or false, then we can suspect that model. We have to suspect that model. So now we'll just deeply look into this. We are having totally 4 assignments, A, B, C, D. And we are having 2 input bits, that is A comma B. The input bit A and B. So I call it as a combination of bits A comma B. So the combination of bits A comma B depends upon the size of the combinations. So because binary is equal to, the value of the binary is equal to 2, and the combination of bits is also 2, that is A comma B, that is equal to 2, that is 2 to the power of 2. So totally there are 4 combinations. So that is 0 0 AB, 0 1 AB, 1 0 AB, and 1 1 AB. So we are having 4 combinations. Since we are having 4 combinations, we can take 4 assignments. Now here, with the values which we use for A comma B, I am using a formula. A implies on B. A and B. Negation of A bidirectional B. So these are the formulas which I am using. Now what I am expecting the model of formula, when I am applying the formula, when I am getting 1 as the result from the equation X, that is A implies B, I can think that X is equal to A implies B. And the assignment is that. And X is equal to A and B, that is also an assignment. And negation of A double bidirectional B is also an assignment. Now when I'm saying that A implies 0 implies 0, 0 can definitely imply on 0, then it is equal to 1. 0 implies on 1, 0 also it can become 1, so 1. 1 is implying 0, 1 want to become a 0, no, so it is false, 0. 1 can become 1, 1 implies on 1, so that is equal to 1. So now what happened when A implies B? Totally there are 4 set of combinations of inputs. So for assignment A and B and D, for assignment A, B and D, we got 1 as output. Okay, so in A, in the conclusion what I am writing is the assignments A, B and D are the models of the formula A comma B. A implies B. That means what? A implies B, the model formula are available in assignment A, B, D. Assignment C is equal to 0. So since is equal to 0, So assignment C cannot be is a model formula. So where we get 1, there only that particular model, we take it as the model. Okay. So now we go to the next equation, that is x is equal to a and b. The opposite v is equal to and. So a and b. So a and b is having the prescribed what we call outputs. It is and is multiplication. 0 multiplied by 0 is equal to 0. 0 multiplied by 1 is equal to 0. 1 multiplied by 0 is equal to 0, and 1 multiplied by 1 is equal to 1. So what is happening when we are having an equation a and b? Only at one position we can expect 1 when all the inputs are 1. Okay. So if you look at the conclusion of B, the assignment D is model of the formula A and B. So for A and B, assignment D is the model of the formula. Why ABC is not? Because ABC is yielding 0. Similarly, negation of A bidirectional B. Okay. Negation of A bidirectional B. So we are having the bidirectional. A comma B is bidirectional. 0 and 0 is a bidirectional. So when we negate it, then that is equal to 1. So what we are doing is we are just making the calculations. So in this model, A and D are yielding 0. So these are the models. A and D are yielding 1. So these are the models. And B and C are yielding 0. So we cannot consider B and C as the model. So similarly, we are working upon model of formula. This is a like homework or classwork, whatever it is. Again, we are having 4 assignments A, B, C, D. A, B are the 2 inputs 0, 0, 0, 1, 1, 0, 1, 1. And we have A, R, B. So that R is equal to addition. 0 plus 0 is equal to 0. 0 plus 1 is equal to 1. 1 plus 0 is equal to 1. 1 plus 1 is equal to 1. It's a binary value. So in this assignments, B, C, D are the models for A and B. Now we are having the other model, negation of A. That is, A will become opposite. A will become 1, 1, 0, 0. And negation of B, B will become 1, 0, 1, 0. Okay. So if you are multiplying these with the models, with the values, then A will give a 0 assignment and D will give a 0. And assignment B and assignment C will yield 1. When assignment B and assignment C are yielding 1, then we can think that these are the models for the particular equation. So AB implies A. Whatever it is, it will become same for A. So it will become all ones. So this is the model. So like that, if you look at the second last one, if you substitute the values of A comma B in the negation and multiplication, you're going to yield 1 at A and D assignments. So these are the models. It's a very simple calculation. So you know, like you need not explain anything with. Next, satisfiable formulas. What is satisfiable formula? If there exists at least one model of a formula, if there exists at least one model of a formula, then the formula is called satisfiable. You are having some assignments. At least one, we have a model formula. then it is satisfied. Otherwise, it is not satisfied. It's a very simple thing. We are, let us say, we are putting four balls in a basket. At least one drops in the basket, then you are satisfied. That is the model of the formula. That's a model formula. Otherwise, you are not satisfied. The value of the formula is true for at least one assignment. As I said, for at least one assignment, the model of the formula must be true. It plays no role how many models the formula has. And again, a beautiful this thing. How many models the formula is having is not a question, but at least one assign must be true. So, if you look at this, what we have done in this, all the models are having at least one. A implies B having three ones. A and B is having a single one. Negation of A bidirectional B is having two ones. And negation of A or B is having one, two, that is one. And or negation of A is having four ones. So in the entire situation, in the entire process, we are having at least one in all the assignments. So since it is called as satisfiable, because they have at least one true, that is one in the model. At least one in the model. Next, valid formulas. A formula is called valid if all assignments are models of this formula. All the assignments of the model this formula, then it is called a valid formula. Suppose if you are asking your friend, he is giving all good suggestions, then you are validating all the suggestions because it is that good. So similarly, a formula is having all the assignments are models, all the assignments are getting one, then it is called a valid formula. The value of the formula is true for all assignments. Okay, so this we'll see in the example itself. So these are the valid formulas. Whatever you do, you are going to get one. For all assignments, we have four assignments. If you look at all the four assignments, you are going to get one. Okay, 1 or 1, that is equal to 1. If A is equal to 0, that is 0 or not A, that is equal to 1. 0 or 1 is 1. If A is equal to 1, 1 or negation of A, that is equal to 0, that is also 1. Next, 0, A implies A is equal to 1, that is 0 or 1 is equal to 1. 1 and A implies A is equal to 1, that is also 1. So all the formulas are absolutely valid. All the formulas are absolutely valid. So when all the assignments are gaining 1 out of their inputs, then it is called validus formula. Next, unsatisfiable formula. So if a formula is not valid, then it is called as unsatisfiable. Because none of the assignments are yielding true and no models are there. If you look at the assignment 1, 0 and 1, that is 0, A and 0. If A is equal to 1, 1 and 0 is a 0. A is equal to 0, 0 and 0 is also equal to 0. A multiplied by negation is always 0. A is equal to 1, negation of A will be 0. A is equal to 0, negation of A will be 1. Then 0. So negation of A B or A negation B implies AB negation A into negation B. If you expand this by substituting the values for A comma B, you will get 0. So here for all the assignments we are yielding 0 only. So these formulas normally we refer as unsatisfiable formula. So, no logical equivalence. Logically they are equal. Though the combination or a sequence may be different of the formula, but logically they are similar. How do you say logically they are similar? Only you need to apply the values for alpha and beta for left hand side and right hand side. What it will give you? Left hand side is similar to right hand side. As an example, I tell you alpha and beta is equal to similar to beta and alpha. You substitute the values of alpha and beta is equal to 0 comma 0. 0 and 0 is equal to 0. 0 and 0 is equal to 0 0. It's a commutativity property that normally comes with and or. So whatever the combination of same values of alpha beta substituted to left hand side and also towards right hand side, then what happens? The result which is developed by left hand side and right hand side will be same. They are similar. We'll go to the third formula. A and B, that is alpha and beta and gamma. So here it is multiplied in the left hand side, alpha and beta is multiplied, then gamma is multiplied. In the right side, beta and gamma multiplied, then alpha is multiplied. It is same. Let us say alpha is equal to 1, beta is equal to 1, gamma is equal to 1. 1 into 1 into 1, 1, 1, 1 into 1, 1, 1. That's all. So this property is called associativity. They are associated equally towards left hand, right hand side. The next one is double negation. Saying continuously no. Let us say I'm asking you to come to college. You are saying that no sir, I cannot come to college. Then I am saying I am not accepting your no. I am saying no to your no. I am saying yes to your no means what? You are okay. No to no is yes. So negation of alpha is equal to alpha. Both the negations will be cancelled. If alpha is equal to 0, the inner bracket negation, that is negation of 0 is equal to 1. The outer bracket negation of 1 is equal to 0. So that means which is the original value of alpha. So alpha, it's called contraposition. Alpha implies beta. That is negation of beta implies to negation of alpha. It's a contraposition. You can just check it. So implication elimination, we are eliminating some implication. Instead of implication we are keeping R, because in mathematics sometimes you cannot keep implication. It's not possible. So if you want to imply elimination, if you have implication, then we have to go for the left variable as negation and implication as R. Next, alpha bidirectional to beta. So that also can be bidirectional, can be eliminated with implication by substituting this formula. Both left and right hand side will be same. Now the next one is De Morgan's law. Alpha and beta is complemented, negated, then all will become reverse. Alpha will become negation of alpha, and will become R. Beta will become negation of beta. So this is called De Morgan's law. According to the De Morgan's law, when A plus B is negated, A will become A bar, B will become multiplication, and B will become B bar. A bar multiplied by B bar if it is A plus B whole bar. Next, distributivity. So it is like what do you call opening the parenthesis? A and B, A and bracket open B are I mean alpha and beta are gamma. So alpha and beta are alpha and gamma distributivity. So we're distributing over and R. Okay. Now the rule deduction. How do you deduce the rule? We have to infer the rule. It is a very interesting topic. So we are inferring some rules. So what happens? There is a problem. Out of the problem, we have to generate so many rules. Not only single rule. We generate 10 rules, 20 rules, 30 rules. When all the 30 rules are grouped together, it will become the formula or it will become some issue. Now let us go with the issue. So there is a scenario. There is a crime scenario. Before looking at this, I'll just tell you the story. What is this? There is a crime scene. There are similar crime scenes are happening in a place, and one police officer is what do you call monitoring all the crime scenes. The name of the police officer is Thompson, and there is a criminal in most of the scenes. His name is McAvity. The police officer name is Thompson, and the criminal name is McAvity. Now, what is happening? The officer Thompson is having allergy with dog hair, dog fur. Normally, the cat and dog hair we call it as fur. The officer Thompson is having the problem with dog fur. And the fellow who is the McAvity, who is a criminal, wherever he go, he take a cat for crime. Okay. So now I'm reducing the rule. Okay. Either cat fur or dog fur was found at the scene of crime. So at any scene of crime, either dog fur is found or cat fur is found. At any scene of crime. Officer Thompson has allergy attack. So the person who is monitoring all these cases, his name is Officer Thompson. He is having an allergy problem. Okay. So how the Officer Thompson is having allergy? If it is seen, dog fur is found. If at the crime scene, dog hair is found, then the officer will have an allergy. If the cat fur is there, normally there is a thief called McAvity. If on the crime scene, if cat fur is found, then this fellow is responsible for the crime. McAvity is the responsible of the crime. So here, the simple rule is, if the officer Thompson is not getting any allergy, it is indicated that the fur found at the crime scene is the cat fur. That means what? The McAvity is responsible for the crime. So in this, now I just wanted to deduce the rules. I just wanted to infer the various rules. The first one is, if I look at the line 1, either cat fur or dog fur was found in the crime scene. So either this or that. Both are not found. Both is and. If one is one means what? R. So C or D. C stands for cat fur or D stands for dog fur. So that is the first line. So I am reducing the rule for the first line. Next, if I go to the second line, if dog fur was found at the crime scene of crime, Officer Thompson has an allergy attack. So from the second line also, I'm taking a rule. So D implies A. If it is a dog fur, it will imply on A, because dog fur officer is having an allergy with dog fur. So D is going to imply on A. Next, going to the third rule of inference. The third line, if cat fur was found at the scene of crime, then McAvity is responsible. If we are having C, C implies McAvity. Cat fur implies McAvity. Okay. How do I know that whether it is cat fur or dog fur? Officer did not get allergy means it is cat fur. Officer got allergy means it is dog fur. Okay. Next, I am generating the next rule. Officer Thompson did not have any allergy. So allergy is negated. No allergy means negation of allergy. Okay. Then dog furs were not found at the scene of crime. So D implies on A or negation A. If the officer is getting the allergy, then it is dog fur. If D is equal to negation of allergy, then it is cat fur. Okay. So if the dog fur was not found, then it is negation of D. It is not dog fur. Then that is equal to C. So we are getting some rule of inferences. If alpha is implies on beta, then we know that negation of B, then negation of alpha. So the entire rule we can draw like this. And similarly, let us say we are having cat fur is found, C. Okay. If it is dog fur, like that we are negating. If it is C, then alpha or beta, and we know not alpha, that is beta. If it is not dog, then it is a cat. If we given alpha or beta, not beta, that is alpha. If it is not cat, then it is dog. If it is not dog, it is a cat. So dog and cat is identified with the officer's allergy. If the officer is having allergy, then it is dog fur. If it is officer is having allergy, then it is dog fur. If it is not having allergy, then it is cat fur. So it is called disjunction. Okay. So like this, the rules are developed. So what is this actually? How I am going to deduce the rule? See, what I want is I wanted to make a rule. If it is raining, then I must carry an umbrella. That's rule number 1. If it is too hot, then also I'll carry an umbrella. Okay. So now the robo is not carrying the umbrella. It is indicated that either it is not raining or it is not very hot. Okay. So if the robo is carrying the umbrella, it is indicated that either it is raining or it is very hot. So like this, I am going to deduce the rule. So what happens here? We need to, why we are going for so many rules, because suppose if I am developing an artificial intelligence system at home. So in the home, what I am making is I just wanted to make my entire home as automated. So I am writing a what you call routine that if the temperature is greater than 28 degrees, then AC must be on. This is my routine. So here what is happening? It will check with the room temperature. Let us say there is a fire accident. Normally, what happens when there is a fire accident? Automatically, all the electrical appliances must be off. But what is my rule? My rule is if the temperature is greater than 28 degrees. When there is a fire accident, within 2 minutes, the temperature will hike up to 28 degrees. Automatically, AC will be on. So what is happening? We are happening in a different direction. We are moving in a different direction. So I have to extend the rules. Every time the rule must be very clear. There should not be any fire accident nearby also. Even suppose in the next building is also there is a fire accident, automatically the room temperature will increase because fire will occupy the entire oxygen. Okay, so this is the way how I am going to infer the rules. The various rules are there. So this is the way how I am going to infer the various rules. So we are having alpha is implying on beta. We know that it is alpha. So this is one of the rule. Okay. So ultimately, what we do is we go through the entire scenario. Suppose if you are explaining the robo that you must give what do you call by looking at the routine, you must understand everything. Artificial intelligence. Let us say X is a person is going to the hotel. The hotel is organized with various robo services. Even in Bangalore also there is a hotel where robo service is available. Now what happens? Suppose in the morning I am going every day to the hotel and I am ordering idli. For suppose if I give the liberty to what do you call robo, as soon as I enters into the hotel and I sit somewhere, the robo will recognize my face and it will run the face recognition software and it will keep a idli on my table. So it is making a rule. The fellow is eating idli since 30 days. That means even the 31st day also, the fellow may not be having a chance. The rule is inferred. Even if you are there also, as a hotel manager, you'll say, please, you'll order that, please give a idli to that gentleman. Which may be which may be wrong. How do I solve this problem? Without taking the order, you are not going to give the supply. And the next thing is, there is one customer. The customer is coming every day to the hotel and is ordering only vegetarian. Now here I wanted to deduce a rule that the customer is a vegetarian. No, you cannot draw this rule because the robo is supplying because his request for the order is only vegetarian. He is not. You cannot draw a rule that he is non-vegetarian. He's only pure vegetarian. He's not a non-vegetarian. No, because some people don't want to eat non-vegetarian in hotels, and some people, what do you call, in the lunch they don't want to eat heavily, so that's why they don't order non-vegetarian. So the rules cannot be inferred just like that. So for every situation you have to take into the consideration. Suppose if the hotel is having a what do you call, separate this thing, are you a vegetarian or non-vegetarian? Then if you say non-vegetarian, then it does not mean that you are a what do you call, you eat only non-veg. You also eat veg. If you say that you keep the vegetarian, then it is clear that you don't eat non-veg. So if you say that if you are a vegetarian, if you are a non-vegetarian, it does not mean that you never touch veg and the robot will not take any order of vegetarian. So we have to be very careful when we are applying the rules. Okay. So this is called rule inference. Let us stop at this point. It's I think 46 to 46. CR of A section. Totally I find 21. Excluding me, it is my 2 logins 19. A section CR.
Yes, sir.
Can you just send me the what do you call presentation numbers, or you want to have a you
So,
want to go to roll call?
sir, can you do roll call today?
You can just take a screenshot.
Okay, so
Paridhi,
yes, sir, I'm here. I am trying to. Many people have already left, I think.
many people already left. No, the total
So,
login, I
sir, there
think.
are hardly 17 children.
Pardon me.
So, there are only 17 children right now in the meeting.
This, yeah, exactly. There are only 17. Okay.
Okay, sir, I've taken the screenshot. I'll just send
Yeah,
it to
you
you.
take the screenshot and segregate and you send me that. Okay.
Okay, sir.
Wow. But see, out of 21, I think two is mine. So 19 is there. Okay. And what I'll do is your number is minus means the D section. D section CR, CR of D section. Sahiti 5J6.
Yes, sir.
Sahiti, can you segregate the number of D section and send me?
Okay, sir.
You take a screenshot.
Okay.
Okay.
Okay,
So
sir.
thank you. So this is the thing. Actually, deduction of rules is a very important topic. Even in IITs also, they give lot of importance for reducing the rules. For this particular job, Amazon and what do you call companies, they're especially they're hiring statisticians because what is the probability for this rule? What is the probability of that rule? That and all. Okay. So please do focused. When is your exam tomorrow or day after tomorrow? Mid examination.
Sir, day after tomorrow, sir.
Day after tomorrow. I think for this subject you don't have any mid examination.
Sir, I don't know, sir. I'll confirm with HOD, sir, and let you know.
Okay, right. Meet in the next week.
Okay, sir.